Welcome to this presentation of heat transfer coefficient of chicken by Cliff Perez and Clint Thomas. What caused us to work on this is the fact that there are currently no existence of the data of the heat coefficient transfer for chicken in the book. So when it comes to parts that's being cooked, there's nothing available for the thermal conductivity. The method that we decided to use was use a conventional oven and to be able to have chicken suspended over it. So what we decided to do was try to get a chicken to be as spherical as possible and have the oven to be at 204 degrees Celsius or 400 degrees Fahrenheit. Using thermocouples, we recorded the ambient temperature, the chicken surface, and the chicken center of the temperatures every 3 minutes. With this data, H and K values would be determined and used to estimate the exact cooking time of the chicken or the final chicken that we will be using. One of the things that made this problem or this experiment to be really interesting is the fact that we had to consider the thermal radiation of the oven. So equation 1 shows the process of doing that. Equation 2 also shows the phase values of the point. So S1 would be the sphere of the chicken, S2 would be the oven. Equation 3 shows that the shape factor method would have been very valuable in this experiment. However, because we could not obtain the emissivity of the oven, we had to neglect the radiation for this experiment. Solving for H, we used a free convection method. In order to do this, we used equations 4, 5, and 6 to be able to find the Rayleigh's number, the Nusselt number, as well as H on the last part of equation 6. These helped us a lot when it comes to this process. With the H value, lumped capacitance was assumed to calculate the Biot number and to then calculate the K value of the chicken. So, in order for us to do that, we had to find the Fourier's number, equation 7, as well as the Biot number in equation 9. Now, in order to do this, we had to assume the K values of the following, or the previous K values mentioned in the book. Once those were attained, we were able to estimate what the Biot number is. Then from there, we used equation 8 to be able to find the Biot number as well. So these processes were used in order for us to obtain this method. Also, lumped capacitance was a value point for this, given the fact that the Biot value was calculated to be around 0.0005. Using this method, we were able to calculate K values for the chicken every 3 minutes. However, values were significantly off. The K values attained were in the 300s and did not match with the given values. For this reason, it is safely assumed that they are inaccurate representations of the thermal conductivity of the chicken. So as you can see in figure 3, the top values were the ones of the thawed, and then the other parts is unthawed. Obviously, they're really way off. Therefore, you could tell that there was something off with this experiment. For the second experiment, it was planned to use the lumped capacitance to calculate the time it would take for the last chicken to cook. In order for us to do this, we would have to use equation 10 in order to solve for time. Using this equation, the average values of the experimentation at K value from the linear trending of the figure that was mentioned before. Estimated time for the center of the chicken is to be about 8 minutes. This number is not close to the actual cook time of 54 minutes. So yeah, basically what our calculations were showing was within 8 minutes we would be able to have the chicken fully cooked. Obviously that did not happen, especially given the fact that it's frozen, and for those of you who were able to cook chicken, you know that it takes a little bit longer than that. As mentioned, where we recorded it was around 54 minutes. Potential errors that were caused during the experiment. Obviously we're mentioning that our values or results that we were coming up with were a little off, or actually really off. So what caused this? Why were they so off? Well, these are some assumptions that we made in order to try to figure out why we were so off. The chickens were not spherically pieces. So we did our best to try to make them into spheres, but in order for us to do that, we would have to chop off a lot, and just chicken itself is not really a spherical type of shape. So that kind of threw us off. Also, when we were running the experiment on one of them, some of the grease fell into the oven and kind of caused a little bit of fire. Therefore, we had to put a pizza sheet at the bottom to catch the grease that would be able to make sure that the fire wouldn't happen. Doing that added a little bit of a thermal radiation. So that kind of threw off a little bit of our calculations. Another thing that we were hoping for was the ambient temperature to be constant. This was not possible given the fact that it would heat up and then kind of cool down and then reheat to that point again. The given K values, the chicken were taken at a 74.4% of water content. We're not really sure the chickens we were using were at the same point, as well as the lump capacitance method was used. So in order for us to make sure that that was the right process, we had to make sure everything else was valid. So that kind of threw us off. Something that we really wanted to achieve with this was finding K values in different objects. Obviously, as I mentioned earlier, the book had the K values of chicken at certain points, but not the points that were really important to us, at least for those who decide to cook. So we wanted to do this in order to try to find the K values of this chicken. So in order for us to do that, this kind of showed the point of being able to find K values in other things as well. So why should engineers care? Well, given the fact that I was actually working at a potato processing plant, I realized that engineers are important for that as well. So why would this be important with chicken? Well, what would happen if you decided to work at a place that needed this? What if one of your managers tried to figure out how to approach cooking chicken in a quicker way or anything like that? Obviously, trying to do an approach like this, using finding K values or anything like that, you can understand the little points of how chicken works, how meat works, how cooking works, and how this can benefit your employers when it comes to future experiment. Thank you so much for watching this video.